Hello, welcome to Bare Metal Machine. I'm Jeff Audia. Today I'm going to be introducing a feature of the Cartesian display called user geometry. Now, this feature allows the machinist right here on the shop floor to go into the Cartesian display and actually make their own geometric constructions. Now, this could be useful for anything from just solving geometry problems to making a correction or an addition to an existing part model. Now, once you've transferred the part model from the CAD workstation into the Cartesian display, it cannot be changed. Unless, of course, you went back to the original CAD model, change it there, and then re-upload it into the display. You can always do that. Now, this sort of one-way street discipline ensures that there's always a master document, the CAD model, that represents the specifications that are being worked to on the shop floor. And so you cannot change the part model out here on the shop floor without breaking that relationship, thus disconnecting the master CAD document from the specifications that the machinist is working to. Well, all this rigidity isn't always going to work, especially in a job shop where time is money. Or maybe the person that made the part model isn't even available. Or maybe it's just a one-off job that you're never going to do again, and it doesn't matter. So there has to be a way of making an exception, and there is. But instead of allowing the machinist to change the part model out here on the shop floor, breaking the connection with engineering, they can do the next best thing, and that is they can add to it. So they can add a feature that corrects the part model or makes up for a feature that's missing from the original part model. And that's what I'm going to demonstrate here today, how out here on the shop floor you can use the Cartesian display to make an addition to an existing part model. Not to change it, but to add something to it, to make up for a mistake or a missing feature. Now, in all honesty, since this is my shop and I'm the one that made the part model, this is just going to be a hypothetical case. I deliberately left some features out of the part model you're about to see in order to illustrate this feature. Okay, so here's the part we're going to be making. It's this triangular thing, okay? And it's going to be machined from this rough stock, okay? And one thing that's kind of funny about this job is that I was committed to the size of the rough stock in this hole location, and I wasn't certain that the part was going to fit perfectly within the rough stock envelope. And so what I did was I went back to the CAD model and I just rotated the geometry this arbitrary angle, right, so that the part would fit comfortably with margins in the rough stock envelope. Okay, so that's why it's the geometry is rotated on that funny angle. Now you're going to see in a minute that it doesn't matter about these angles. Oh, 11.466. What is that? It's nothing. I just rotated it until it looked good. And look at the rest of the angles that represent the part geometry. They're all weird fractional angles, okay? And if you've watched any of my videos in the past regarding the Cartesian display and its integration with the computerized rotary table, it's not going to matter. It doesn't matter that I rotated it this funny angle here, because it's all embodied in the part model, and the Cartesian display will command the rotary table to move to these fractional degrees without any difficulty at all, and we will never have to concern ourselves with these funny angles, okay? Now, so later on, we're going to see the whole point of this video is that these holes are missing. You're going to see and when we go over to the Cartesian display that there's no holes in it. And the reason is that, like I said earlier, I deliberately left them out of the part model to make this point. And not only are they not in the part model, but they're not even in the right place. The holes belong in these corners. Look at the actual part, right? The holes belong in this little inner triangle here in these corners. They don't belong out here. So this is the correction that we're going to make to the part model a little bit later on, okay? And we're going to be doing the geometry to put in these holes, okay? Okay, all this talk about triangles. Recently I happened to be watching a Joe Piezinski video where he puts on an impressive demonstration of trigonometry in order to do the computations necessary to machine a triangular shaped pocket. And he's using a rotary table along with some kind of alignment tool that I believe he invented. The thing you're going to take away from this video is that using the Cartesian display and the computerized rotary table, the machinist has no notion of triangle in his mind when he's machining this thing. He's simply using the Cartesian display to manipulate the tool about the geometry. You know, if it happens to turn out to be a triangle, that's simply a byproduct of, you know, using the system the way it's intended to be used. And so I guess the biggest difference between the demonstration that Joe put on and what you're about to see here is that, you know, there's no nice angles. Like a challenging part like this, it has no nice angles like 30 degrees or 45 degrees, nothing like that. They're all weird fractional angles, as you just saw. And you're about to see that it doesn't matter what the angles are. Now, as usual, I'm not going to go into a lot of detail about my machining process. I only have to make a few of these things, so it's not really a very highly refined process. So don't rank on my machining strategy. It just is what it is. So if you want to learn about machining techniques and trigonometry and things like that, watch Joe Pye. If you want to see how it's possible to make a challenging part like this without knowing any math at all, stick around. Okay, to machine this part, we're going to be using an ordinary Bridgeport style knee mill and with a rotary table installed. This is my computerized rotary table, and the first thing we have to do to get the setup going is to find the physical center of rotation. So I'm using a long stylus indicator to reach down into the bushing inside the rotary table to find XY0. Okay, this will be physical XY0. Okay, then we go to our DRO and we set 0, 0, and then on the Cartesian display we go to Menu, System, Set XY0, and now we got 0, 0, 0, 0. Now the Cartesian display and the DRO are married together. And we'll be machining the part in a vise, so let's get that installed. Next, we need to indicate this vise jaw so that it's parallel to the x-axis. The same way that you would do as if the vise was on the bed of the machine, except now it's on the rotary table, and so we have to tweak the angle of the rotary table until it's straight. Okay, and then we're going to establish that as 0 degrees. So a rotary table, when it's in this configuration, where it rotates about the z-axis, this is called the c-axis. So we're setting c-axis 0 degrees. Okay, now to set c-axis 0, we need to find 2 points on this vise jaw, one here and one here. Okay, now we go to auto 0 mode, and it says locate the first point, hit OK. We're at the first point, so OK. Now locate second point, hit OK. Let's go find the second point. Doesn't matter how far apart these are. Well, it sort of matters. The farther apart, the better. The more accurate your reading will be. So I'm just moving it, you know, an arbitrary distance in x. Okay, there's our second point. Now we got to get the indicator out of the way, because when it computes the adjustment angle, the table's going to move. Okay, so the table's adjusted itself. Now let's check it. Okay, that looks pretty good. So that is now c-axis 0. Okay, so what I did was I went to Menu, Rotary, Auto 0. It says locate first point and hit OK. I was at the first point, so I hit OK. Then locate second point. Right. Find the second point. Now get the indicator up out of the way because the table's about to move. I hit OK. And the table adjusts itself and it sets it to c-axis 0, and we're good to go. All right, now we can load up some rough stock. Okay, one last thing, we have to indicate this hole in because this is the origin of the part geometry. Okay, recall that the physical center of rotation of the rotary table where the x and y axes cross, that's 0, 0. But the origin of the part geometry is where I indicated that hole a minute ago, and that's where this tool location is here. That's where the indicator is. So I need to translate the geometry from this origin up to where the indicator location is. So I go to Menu, Translate to Tool Position. Right? So now this is technically 0, 0 in terms of the part geometry, and this is the physical center of rotation. So now the Cartesian display has what it needs so that when we rotate things around, all the geometry will be where it needs to be. Okay, a little about the machining strategy I'm going to use here. I'm going to machine with a 1/2" end mill around the perimeter of this triangle, and what I'm going to do is I'm going to put these lines parallel to the x or y axes one by one, and I'm just going to make several passes going down in Z until I get to the depth I want, and I'll be leaving some material on each of these surfaces so that I can finish all 3 of them in the end, and I'll make 1 or 2 passes around the whole perimeter to bring in these final dimensions. Okay, so the first thing I need to do is set my tool, which is going to be a 1/2" end mill. Okay, it was already set. Now I want radar mode normal. Okay, so now the first line I'm going to machine, let's say, is going to be this one. That's line 6. Okay, and now I'm going to say align with X. Okay, now I got that line parallel to the x-axis. I can come in here, right, and I can set my Z depth, and I can make a pass. And notice I'm leaving material, right? Look at the gap between the tool and the line, right? I'm staying away from it optically, and and I'll make however many passes I need to get to the bottom, right? Then I'm going to go to, say, this line, and I'm going to say make that parallel to the x-axis, okay? Right? Right? Then I'm going to come down in Z, set my Z depth, and then I'm going to make a few passes in Z like this. Okay. And then I'm going to set this line here parallel to the y-axis. Okay. And again, bring my Z down to depth and make however many passes I need at different Z depths to get to the bottom. Okay, all right, that's going to be the roughing strategy. Now to finish it, what I'm going to do is I'm going to start over. I'm going to go line this thing with X. Okay, then I'm going to bring my radar up to, or down to, rather, 0. Right, watch the radar. Just pretend that was 0. Okay, and I'm going to finish, I'm going to climb cut and finish this wall. Right. And I'm going to make this one parallel to the x-axis. Right. And once again, I'm doing this at the full Z depth, by the way. And I'm going to set my radar to 0. Okay. And then I'll make this finish cut. Finally, I'll make this surface parallel to the y-axis. Okay. And radar 0. Okay. And voila, I've just roughed and finished the perimeter of the outer triangle. Okay, while I've still got this 1/2" end mill in the spindle, I'm going to use it to hog out the material in this inner triangle. Okay, so I'm going to clear the screen here, and then I'm going to put, let's see, this line parallel to X, right? And I'm just going to come in here. I'm going to take a few different Z passes, and I'm just going to kind of freehand the end mill around here a little bit. There's not a lot of room to navigate inside here, so I'm just going to come in here and freehand it and just hog all that metal out of there the best I can with this tool. Okay, and then we're going to go in with progressively smaller tools to get into these corners and stuff. Okay, so I'm just going to take advantage of that 1/2" end mill while I've got it. All right, now I'm going to switch the tool to a 5/16 end mill, and I'm going to use that tool to semi-finish this interior triangle. Right, so there's still a lot of meat in these corners, right? So now what I'm going to do is I'm going to leave 10/1000ths of stock on each one of these walls. So I'm going to get down to within about 10 here. All right, close enough. Now I'm going to feed into this wall. I'm sorry, I'm going to feed into this corner, okay, but I got to do it slowly because there's still a lot of meat in there, right? So I need to know where to stop, right? So I need to put that on radar. So I'm feeding into that corner and I'm watching the radar, and when I get to around 10, I'm going to stop. Good. Okay, now I can just feed along this way. Now I need to know where to stop when I'm feeding into this corner, so I need that on radar. Okay, so we're feeding in slowly. Okay, and I'll stop when I get to about 10. All right. Okay, good. Now get the tool up out of there. Now I'm going to make this parallel to X. All right, get the tool back down into there. Get myself to within 10/1000ths of that wall. Okay. Now I'm going to feed into this corner. I don't have to be as careful this time because most of that metal's already out of there. So I can just visually go by the lines. Now, that's a good place to stop right there. Now feed along this wall. Now this is the last corner that has a lot of meat in it, okay? So I'm going to put that on radar so I know where to stop. Slowly feeding into that corner, right? We're taking a lot of metal. So when I get to within about 10 here, I'm going to bail. Okay, good. Get the tool up out of there. Now I'm going to make this parallel to Y. Okay. All right. Now I'm going to get myself within 10/1000ths of that wall. All right. And once again, most of the meat is already out of these corners, so I can just back into that corner a little bit, just visually stay away from that line. And I can machine along this wall until I get, visually within range of this wall here. Remember, that metal's already gone out of there. Okay, so now I've just semi-finished all these walls and all these corners. So now I'm just going to do the same thing, except I'm going to go to 5/1000ths of an inch. I'm going to leave 5/1000ths of an inch on each wall. Okay, I'm just going to climb cut all around, leaving 5/1000ths. And I won't have to be as careful in the corners this time. And that will leave, this operation will leave the part well postured for our finish pass, which is going to be done with a 1/4 inch end mill. These are 1/4 inch radiuses. I'm sorry, they're 1/8 inch radiuses. We'll be using a 1/4 inch end mill. Okay, and that'll be our final pass. We'll do that next. Now for the finish pass, I'm basically going to do the same thing. I'm not going to rehearse this one. I'm just going to switch to a 1/4 inch end mill, and I'm going to do basically the same thing. I'm going to climb cut around the interior of this triangle. I'll probably take 2 passes, and I'll leave a few thousandths on the first pass. And then I'm going to finish the bottom of this pocket. Right? There's just like maybe 5 thousandths left on the bottom of this pocket, and then I'm going to come in here and I'm going to machine this little inner triangle, which is, it's just at a slightly different depth than this pocket here is. Okay, and then we'll be done. Okay, one last detail for this milling operation. You may have noticed by looking at the Cartesian display up to this point that these 3 holes in these corners are missing from the part model. In fact, in full disclosure, since I'm the one that prepared the part model, it's no mistake. I left them out deliberately, and it is the purpose of this case study. Not only are the holes missing from the part model, but even the sketch is wrong. The holes don't belong in these corners. They belong in these corners of this little triangle, this little inner triangle, similar to this part here that was made earlier. This is a similar part. Okay, so, let's say you're on the night shift and you make this discovery. The engineer's gone home and you got to get these parts done, so what can you do? Well, once the part model's been loaded into the display, you can't edit it, you can't change it, but you can do the next best thing, and that is you can add to it. So that's what we're going to do. Okay, recall that all of the geometric entities in the part model, they all have names. Like, for instance, this is line 8, line 9, circle 1, arc 2, A02, right? So, you know, these names, they pop up on radar, and they're also the names that you would use if you wanted to use the find button to find a given line. Like I could say, I could hit the find button and I could type in L05 and it will put this line on radar, okay? So since we can refer to these entities by name, well, then we can make other pieces of geometry that are relative to them. For instance, I happen to know that these holes are 0.125 away from the wall. And even though this is the incorrect sketch, they belong on the inside. So they're 0.125 away from this wall, and this wall, okay? So if I could simply place a line there, for instance, if I could say make a line parallel to line 8, but offset by 0.125, and then if I could make a line parallel to say line 9 and offset by 0.125, then I would have an intersection point here. And that's where the hole belongs, right? At that intersection of these two lines. And so I can do that. I can define this line, and I can define the intersection of that, these two lines and make that point. And I can even put a circle there if I like, okay? So that's what we're going to do on the Cartesian display now. We're going to go over there and we're going to define these lines, and they are going to become part of our part model. And I will be able to use them on radar, and I will be able to navigate to these points and drill these holes. Okay, so of course there'll be we'll define 3 lines actually, right? So I'll define at a 125 offset from each one of these things. So I'll have a point here, a point here, and a point here, and I'll be able to use the radar to navigate to these lines, to these points, and we can pop these holes in, okay? Okay, so to define this geometry, it's called user geometry, by the way. So anything that we've added to the model, it's called user geometry. Like everything in white, this is part geometry, right? That's the part model. And anything that we add to it, you'll see in a second, it's going to show up in purple. That's user geometry. Okay, so we go to menu and geometry. And you have some choices here, lines, points, circles. So we want lines, and there's several choices. And the one we want is parallel. We want a line parallel. Okay, so parallel to what? L, and the first line we said was line 8. So we 8, and then we hit OK. And then it says XL. So what is it asking for? XL, X large, X small, Y large, Y small. You pick the one that best describes the orientation you want. Because remember, if it's parallel, there's 2 choices, right? In the case of that line 8, it could be above the line or it could be below the line. So we want the line that's Y small of line 8, right? So enter, and how far off is it? It's 0.125. That's the offset. Okay, hit OK. Okay, and so there it is. So remember, that's line 8. And this is a line parallel to line 8, but offset by 0.125. Okay, let's do another. Lines, parallel. Okay, this time line 9. Okay, now we want the one, there's 2 choices. It could be X large, which would be out here, or it could be X small, which would be in here. So we want X small. X small, 0.125. Okay? And by the way, it's naming these lines as we go. So that's line 22, so we want to write these down. The first one was line 21. Okay, so let's do another. Let's do parallel. And this time it's line 7, which is this line on the bottom. Okay, 7. Okay, and this time we want Y large, right? We want the one whose Y component is larger, because that would be the one up here. Y small would be down here. So we want Y large, enter, 0.125. There's our offset. Enter. Okay? So there, and that was line 23. Okay? So now we can make points at the intersections of these lines. So we can go to points, and I'm going to say int of line 21, okay, and line 22. Right? That's going to be this point right here. Okay, and there it is. There's that point, point 24. Now let's make a point at the intersection of line 22 and line 23. That's going to be this point right here. Okay, and that's point 27. Okay, this point here that popped up was because I hit the OK button twice, and it gave me a point at the tool position, which happens to be right here. So just ignore that for a second. Okay, so now one more. Point into line 21, which is this line, and line 23, which is this bottom line. Okay, and there's point 28 right there. Okay. Let's see. Okay, now let's make some circles here. Even though we don't really need the circles, but we'll put them in anyways just for kicks. Because with the radar, we can go to points mode, and I can navigate to these points just as easily as I could navigate to a circle. Basically, circles and points are interchangeable. But we'll put the circles in anyways just to make sure, because who knows, maybe if we draw the circle, we'll discover that something's wrong. And so we'll put the circle in just as a reference. Circle. And we're going to say center, and that's going to be point 24, and the radius is, we'll just say 0.062, right? And there it is, there's our first circle, right? And that's called circle 29. Now let's do another one. Circle center is at point 25, and the radius is 0.062, right? And that should be right here, okay? And one more, let's go center, let's say it's point 28, right, because this is point 28, and we will say 0.062, and voila. Now we've got, we've just basically corrected the drawing, and we've got some user geometry in here that represents the geometry that was left out of the part model, okay? And let's see, now we go, yeah, now we're back to our regular home screen, and we can see that our user geometry. And now we can go to radar, and we can use either points mode or holes mode, and we can navigate to these holes, and we can drill them in just like it was any other hole in the part model. Okay, so now that we have some user geometry defined and it's displayed, and now if you get out of the geometry mode and it's not displayed, you just need to go to modes, and you need to select display user, okay, and it will turn on the user geometry. Otherwise, you can shut it off and turn it on at will. So you can do everything that you could do with the part model geometry. You know, you can zoom in, you know, and you can pan and zoom the part just like before. There's no distinction between user and part model geometry. Although you do have to pick which mode you want to use for radar. For instance, if I want to use the radar mode, so I'm in radar normal, right? So line 1 is on radar, and it's showing that I'm 0.07 from that line, right? I'll get closer to it, the radar goes down, right? So if I want to use user geometry on radar, I have to use this button here, part/user. This will toggle between part model and user geometry mode. So if I pick user, right, now you see it's picked line 21, which I don't know if you remember, but that was this line here, line 21, right? So if I move the tool closer to it, you see radar is indeed paying attention to line 21, right? And I can toggle back and forth. I can go back to part model, and I'm this far away from line 1, user, this far away from line 21. Okay, so you can navigate the display just like the part model, and you can use radar. You just have to pick which set of geometry you're referring to, either part model geometry or user geometry. Okay, so for instance, if I wanted to drill these 3 holes, right, that's the last part of this operation, I might want to change the tool size, even though the tool size is actually irrelevant when it comes to using radar in, let's say, holes mode, okay? So this tells it that I'm navigating to the center of a hole, okay? So I just move the tool like normal, and I use the radar. So this one, circle 29, that popped up on radar first. So when you're in holes mode, it'll only pick holes. So I go next, and that's circle 30, circle 31, and back to 29. See, it only goes to holes. or points or whatever you happen to have it set to, okay? So let's say C29. Okay, and so now you just use the radar and you use the D and the DX and the DY to navigate to the hole like you would navigate to any other hole, okay? So I'm going to move Y up. It's telling me I got to go up another 6 thousandths. Here we go. Pretty close. Okay, now X is saying minus 0.02, so move that over until DX is 0 or thereabouts. Okay, so you see I'm damn close to the center of that hole. I can get it exactly on if I want to fuss about it, but there it is. So now I can go ahead and I can drill that hole, and I'll do the same thing for the rest of these holes, and then this operation will be finished. Okay, so here's the final result of this milling and drilling operation. I'm not going to show any further operations like where I trim away this material and so that the part ends up looking like one of these. Okay, the video is already long enough. What I wanted to demonstrate as a case study is the ability of the Cartesian display to define geometry that's not in the part model. So in this case here, recall that the positions of these holes, not only are they wrong on the sketch, but they were never even included in the part model. So I was able to use the user geometry feature to define the positions of these holes so that I could machine them. And that's it. That's the result. And thanks for watching. Okay, wait, before we quit here, let's just have a peek at some of these dimensions. And let me remind you that during the machining of these parts, at no time was there ever a point where I picked up a micrometer or a caliper and made any kind of in-process measurement or adjustment. The only time I ever actually measured anything was this 1/4-inch end mill that I used to finish the interior triangle. I needed to measure that so that I could tell the display precisely what the diameter of this tool was, and it turns out it was like 2.246. And the Cartesian display needs to know that so that it can compensate for that. And that's the only measurement or adjustment that I actually made, was telling it the literal physical diameter of this tool. Okay, so let's just start with the wall thicknesses I happen to know are supposed to be 0.187. So let's just take a peek at some of these. And looks like 188. Okay, try this one. This is 188 and maybe 189. Okay, so those are really close. Now these distances from these peaks of these triangular corners, these are a little more challenging to get. So like 2.4. Let's try that. I think the thing to do is to get it within the jaws and just like roll the part to find the high point. Okay. So this, it looks like this could be around 2.397, 3.075. Let's try that one. Okay. It's awfully difficult to do on camera also, because I'm not holding everything the way I'd like to. 3.0. This looks like 3.076. Okay, and now this one, 3.508. Let's try that. Okay, this looks like it could be 3.509, 3.51, somewhere in that neighborhood. These are probably all within 1 or 2 thousandths of what they're supposed to be. Now, as far as measuring all of those funny fractional angles. That's not going to happen, not here. But by the law of sines, given that these legs of these triangles are within a certain a few thousandths of their target dimensions, you can mathematically infer what these angles must be. I'm not going to go down that mathematical rabbit hole right here, but anyways, you can see that without any in-process measurements or adjustments, the part is darn close. Okay, so that's a wrap. Oh wait, here's a dimension we should probably look at. The distance from, something I can do with calipers. The distance from the center of the hole to each one of these edges is 0.805. But I have another sheet here that shows from the outside diameter to each one of these edges is supposed to be 0.555, 3 places. Now, the hole is actually reamed to size, so I know it's within a thousandth of an inch. So let's just have a peek at some of these. Okay. Let me move this. That is 0.555 and maybe a few tenths. Of course, we're not usually talking about tenths with a caliper, but this looks like 555 on the nose, and this is maybe 556. Okay, so that's a good sign. So there it is. Thank you.